Oftentimes when we're solving compound interest problems, we have a lot of different things going on. And so the idea is that we can use the TVM solver to calculate at each point and then somehow piece it all together. So let's suppose that you speak with your financial advisor and he sets up this plan for you. So he says, you can invest in a CD, which is a certificate of deposit. Essentially, you drop in a lump sum of money and they promise you 4% compounded quarterly for 3 years. After that time, he says, I think you're going to be able to reinvest in a new CD at 3% compounded monthly for a 2-year CD. We expect rates to be a little bit lower. And then we'll invest that money in a money market account after that point at 2% for 10 years. That'll be safe. Money market accounts are pretty stable for the most part. And then after that, you're ready to retire, and your goal is to be able to withdraw $2,000 per month in pure interest. That way, your bank account balance never decays at a rate of 1% per month, or I should say, compounded monthly. So we have our timeline, and we'll draw our time diagram. And so we'll put over here that this is going to be at, let's see, so 3 years plus 2 years plus 10 years, that's 15 years. So after 15 years, you need to be able to withdraw $2,000 a month in pure interest. And this is time equals 0 years. Now we know we have these key points here. So our first key point is that after 3 years, we're going to have to sort of recompute. So we'll say 3 years is right about here. And then after 2 years beyond that, you're going to have to readjust. After 10 years beyond that, after this 15-year mark, that's where we need to ensure that we have our total lump sum of money. Well, the first thing we have to figure out is for me to be able to withdraw $2,000 per month in pure interest at a rate of 1% compounded monthly. So 1% compounded monthly is going to be 0.01 divided by 12. That's going to be our monthly interest rate. Okay, but the interest that's going to be applied to is some amount. I don't know what that amount is. I'm just going to call it X. But whatever that amount is, when I take 0.01 divided by 12 of it, I want to make sure that that amounts to $2,000. In other words, the bank is just paying me $2,000 each month in interest dollars. What I'm going to do is I'm going to withdraw that money, spend it, and that way my balance never actually changes. So it's kind of this idea that if this stack represents your current money, then every month the bank basically puts on or stacks on an extra $2,000. You withdraw that money, putting you back at X dollars, and then the month after that they pay you $2,000 in interest again. You spend it, it drops you back down to X dollars. So you're never actually touching the principal amount of money that you have in the bank account at that time. So if I solve this equation, in other words, if I take X and now I solve for X, 12 divided by 0.01 times 2,000, so multiplying or dividing both sides by 0.01 divided by 12 is the same thing as multiplying both sides by 12 over 0.01. So if I take 2,000 divided by 0.01 and I multiply it by 2,000, I get a huge sum of money, which is 4,000,000,000,000. Let me count. 1, 2, 3, 4, 5, 6, 7, 8. I have 8 zeros. I have 8 zeros here as well. So that's going to be a lump sum of money of $400 million. I would have to have $400 million in that bank account in order to be able to get on this amount $2,000 in interest on a monthly basis. But let's go with it. Okay, so we know that at this point, after 15 years, my future value should be $400 million. Now, the reason this is so big is because the interest rate is so small. This is 1% compounded monthly, so that means that that's 1/12% per month. Now I've got to work backwards. The question is, how much do I need to invest today? I need to get this original present value. Now, unfortunately, I can't just use the TVM solver to say, 15 years and calculate the present value based on some interest rate, because interest rate continues to change over these periods. So what I'm going to have to do is, first of all, think about this 13-year window right here. So I'm going to focus on just this 13-year window. And I'm going to think about this as sort of time 0 and time 13 because, again, that's just a 13-year period that we're considering. And this is going to be at I% equals, well, this is 2% over that time period. And this is for 10 years. We didn't specify, but let's go ahead and write that we're going to compound daily, just to give this problem some extra flair. So that means my N, my capital N, is going to have to be, well, it's 365 annual compoundings multiplied by 13 years. My present value is unknown. My present value is going to be, for that 13-year window, this value over here. Now my PY, my PMT, I'm not making any monthly payments or daily payments, so PMT is going to be 0. That's something we'll explore later on as to what if we make regular deposits, which is more realistic, but again, we're just learning how to solve problems here. PY is going to be 365, CY is going to be 365. All right, great. So let's go ahead and do this in TVM Solver. I've got that set up here. 4,745 is the total number of days, or the total number of compounding periods that are going to take place over 13 years. So you can enter 365 times 13. Again, total number of compoundings, 4,745. The annual rate was 2% in this money market account. We don't know present value yet. We're going to solve for it. PMT is 0. Our future value is 400 million. PY and CY are both 365, representing the number of compoundings. So solve for present value. This tells me that 13 years ago, I should have invested through, let's see what this number is. This is about $308,422,831.22. So let's go ahead and copy this value. Okay, here we have that back in our time diagram. And that kind of makes sense, right? $308 million to get $400 million 13 years later at an interest rate of 2%. So we gain about 33% value on our account over the course of that 13-year period. Okay, well, that doesn't tell us what we need at time 0 because I still have 5 years across which that 308 million was earning interest. So now what I need to do is I'm going to backtrack once again over this actually should have said 5 years total, because that would have been for an extra 2 years. Okay, so now we're going to backtrack over that period of time. So I'll just draw another little diagram here. That's kind of these little mini time diagrams that help us do the computation. So my future value that I need at time, in this case is going to be time 2 years, and time 3 is representative of 0. So just think about this as one investment period. Our future value is the $308,422,831.22. I need to know, what did I need to have 2 years before that? So that's my question mark. My I% over that window is equal to 3. My N, well, this is compounded monthly, so this is going to be 12 times 2. That's going to be 24 months of compounding. PMT is going to be 0. PY and CY are both going to be, I'll just write PY equals CY, which is equal to 12. And now I'm going to figure out what that present value is. Okay, so now we have that information in here. I want to solve for present value. You don't necessarily need to clear it, but 24 months, 3%, future value that I require after those 24 months is the 380 million. PYCY are 12. Solve for present value. Okay, that amount is smaller. So this means that I need to invest at this time 0. Let me take out the question mark now. Question mark is gone. That is the amount that we need at that time in order to accomplish our goal of $308,422,831.22 at the 5-year mark. And guess what? Now we're going to do the same thing for the 3-year period. And for that 3-year period from time, which is actually time 0 to time 3, we need to make sure that our future value at this time, I'm going to kind of do a little arrow here, our future value needs to be this $290,483,432.99. This is at time 3 years from time 0 years. What we're now going to find out is what should be the original present value at the time 0 today, how much we need to invest today to reach that goal of 400 million in order to be able to withdraw $2,000 a month for however long we live. So our I% in this case is the highest of them. It's the 4%. It's the 4% compounded quarterly. That's 4 times a year, and that's going to be for 3 years. So this is going to be 3, or we could write 4 times 3. 4 compoundings per year multiplied by 3 years. Our payment is 0. Our number of compoundings per year, which is both PY and CY, is equal to 4. Remember, we don't, at least for the TVM solver, we're not going to change PY and CY. There'll always be 4 for us. And now we can work backwards to figure out what PV needs to be. All right, here we have our inputs. We'll solve for present value. That tells me that at the original time 0, we need $257,789,297.56. That's the amount that we need to invest today. So this amount here is negative, which is negative because we need to spend that money today. $257,789,297.56. So that means that this is not the best financial advisor, although it's a goal. It's a very lofty one because you would need to invest this today in order to achieve your goal after 15 years. Now, this is purely for the exercise of just learning how to navigate the time diagram. This is not a realistic example, but we can nonetheless calculate it. We can use the power of the TVM solver to solve problems that come in sort of these multiple pieces and really forces us to think about what it is that we're solving for.